Welcome to Unit 8, Trigonometric Algebra, and this is a mix of what we have learned in Algebra 2 and some of the things that we have learned in Algebra 1, as well as things that you have already learned in Trig class, and of course the new stuff. So the first thing we're going to do in this video is review the basics, and let's get right to that. So a review of the basics. What do you need to know to be successful in this unit? First thing we need to know is what quadrants are the trig functions positive and negative. And we went over this by relating them to the fact that x is cosine and y is sine. So when you use that idea, all functions are positive in quadrant 1 because x is positive in quadrant 1, y is positive in quadrant 1. And if you remember from a previous unit, the tangent is equal to y divided by x. So if you divide two positive numbers, you get a positive. In quadrant 2, y is positive, so sine is positive. But over here, x is negative, so cosine is negative. And if I divide a positive number by a negative number, I get a negative, so tangent will be negative in quadrant 2. So I've listed only the positive function here. If we go to quadrant 3, the x values down here are negative and the y values down here are negative, meaning that both sine and cosine are negative. And if we divide two negative numbers by each other, we get a positive. So that means that tangent will be positive down here. If we go over here to look at cosine, cosine represents the x values. So x is positive, y values are negative below the x-axis, so the cosine value is positive, sine value is negative, and if you take a negative divided by a positive, you get a negative, so tangent is going to be negative down here. The next thing that you need to know is how to find other trig functions when you know one of them. So if you're given a scenario where sine of your angle, spelled angle wrong, angle is equal to 3 over 5, you need to know that you are in a right triangle. So let's get a shape, a right triangle, and that you can mark your given angle. I'm going to mark my angle down here. Let's call it theta. And sine is really opposite over hypotenuse. So I can label this as opposite of theta is 3, the hypotenuse is 5. Use the Pythagorean theorem to solve for this side down here. Some of you already know the answer to this, and I don't need to go through the Pythagorean theorem. Let's call this x squared equals 5 squared. And when you solve this, you can go ahead and verify this yourself. You get that x is 4. So that means that this side is 4. Once you know that, you could find the cosine of your angle. And the cosine of the angle is adjacent over hypotenuse, so that's going to be 4/5. And you could find the tangent of the angle, because that is opposite over adjacent. And so the opposite of your theta is 3, the adjacent is 4, so this is going to be 3/4. If we move down here, the other things you need to know is how to get the sine, cosine, and tangent values of the common angles. What I recommend is that you actually go through and remember that unit circle here, and that the x value here is 1, the y value here is 0. And you remember that cosine is x and y is sine, and that will help you to get the 0, 90, 180, and 270 x and y values, so sine and cosine, and you can divide them to get tangent. But if you are going to try to look for the 30, 45, and 60 angles, you're better off going to drawing your triangles. And so we need to draw a triangle to be able to find that. So if you're going to do that, we know that you have the 45 here, so this is going to be a 1, 1, and square root of 2 in your 45, 45, 90 triangle. And in your 30, 60, 90 triangle, you have 1, 2, and the square root of 3. Oh, it's going off my other writing. And then you can use SOHCAHTOA to help you get those. Now, some of you remembered them other ways. There's the chart where you count up and count down to get sine and cosine. It doesn't matter to me what method you use if you know the decimals and you can convert back. If we're looking for sine of 30, sine of 60, let's go with you, and it says exact. If you're doing the sine of 60 and you give me a decimal value and it says exact, you missed the concept. It's half the points off. So let's not go there. Let's make sure that you know the sine of 60 is opposite over hypotenuse, which would give us square root of 3 over 2. And so once you know that, you can maneuver from there. Okay, and if you know, however, you put the sine of 60 in your calculator, you get 8.8660. If you're one of those people who can memorize well, then take the 0.8660 and remember that it is this fraction and put that fraction down on your paper. And we also need to remember how to find the reference angles from the previous chapter. So in this quadrant, the theta is your reference angle. And of course, if you remember, your reference angle is an acute angle, and it is the angle made with the x-axis. So I'm going to label these as R's. This is a reference angle. This is the reference angle. This is the reference angle. And this is a reference angle. It's always the angle made with the x-axis, and it is always acute. And here are the formulas for remembering it in terms of degrees. Okay, those are all the basic things that you need to know. Please review them as much as you need to throughout the chapter and go back and watch this again. These are assumed that you know as we proceed through the videos.